All right, what's up? Today we're going to talk about Docker networks. So let's go over to my Docker host. I call it Webby because he's got some websites on him. Okay, what we're going to do here is I'm going to just elevate to sudo right away because then that way I don't have to keep on typing it. You should always have a long, complex password. So hope that's long enough. What we're going to do here is we're going to say Docker networks, Docker network, excuse me, not networks, but network, and ls. And we're going to just take a look at the networks that we do have in here. You see I've got 4 different networks and I've got 3 different driver types. So let's talk you through some of the drivers that we have. I'll start you at the bottom of the list. If you have a network with the driver of null, containers deployed into it will not be communicating with themselves, they'll not be communicating with each other, they'll not be communicating with the outside world, they'll be communicating with the Docker host, and that's it. It's a black hole. So aptly put, null. It's the none network. It ships by default, as does host. The host driver with a network called host, if you are to deploy a container into host, it will have the same IP address as your host. So in my case here, it's going to pick up the IP address of 10.30.0.195. And it's very helpful, very useful if you need to communicate directly to that Docker container from another machine in your network. And that is because, let's contrast that with bridge. So networks with the driver of bridge, they are NATed. So unless you have a route set up so that you can reach back and forth into your bridge, you won't be able to communicate with them typically. That's where you would want to use your host bridge and your host network. One of the things here, you can see I've got 2 different bridge driver networks. One called Ghost default and the other one called Bridge. The one called Bridge ships by default by Docker, and that's where all of your containers will be deployed unless you specify. Now, if you read the documentation, Docker does specify, they say you really want to use a user-defined network. User-defined bridges with a bridge driver, they're basically going to look and feel like a firewalled VLAN. They're going to get that same NAT treatment so that it's hard to reach them unless you're on the Docker host itself. And containers within this particular network, they will not be able to communicate with containers in another bridge network. So kind of firewalled and VLAN. As far as VLANs go, VLAN being an overlay for IP subnets, they will have the IP address of 172/0/0/0, whatever, /16. It's, like I said before, unless you set up a static route so that you can reach your Docker containers, you won't be able to establish traffic from outside of your Docker host down to these particular containers. So that's where, like I said before, putting them in the host network will come into play. But there does come a time where you want a container that does not share the same IP address with your host, and that's the 4th network that I wanted to talk to you about today. And in order to do that, we're going to create one. So I'm going to say Docker network create, and we're going to use the driver of Mac VLAN. Okay, and then we're going to set up the subnet. In this case, I'm going to use 10.30.0.0/24 because that's my DMZ subnet anyway. You do need a gateway if you're planning on getting your traffic off of your subnet. And in my case, it's 10.30.0.1. And we're going to need to talk about an option here. So tag O for option, and parent equals the name of the interface. So ENS18. And the reason why that's important is because with Mac VLAN, you're using your MAC address for another container on this same subnet. And it's going to be squeezed down through the physical interface. Now, this only works when you enable promiscuous mode. So if it doesn't work, go back and double check, make sure that you have promiscuous mode so that you can allow multiple MAC addresses on a physical interface. And in my case, like I said, ENS18 is the name of the physical interface. We do need to name this particular network, so let's name it DMZ, and that should create it. It looks like we have created it. We got the gobbledygook. Let's go ahead and confirm it. Docker network ls. And we can see we have a new network with the name of DMZ, driver of Mac VLAN. Doesn't mean anything unless we set up and configure a container to run in there. So let's do that. Docker run IT to make it interactive. We'll tack it up with a D so it's attached. We're going to name him Bill. Bill is going to get the IP address of, let's see here, 10.30.0.123, let's call him. We'll put him in a network of DMZ. And lastly, let's give him the image of Ubuntu. All looks right to me. Looks like it is right. Okay, let's go ahead and exec Docker exec into Bill. Make that interactive. I'll say Bill. And we'll say bin bash. Okay. We got a shell type. Good. Now, in order to check the IP address, because this is such a basic base image, we have to apt update first. And apt install nettools and IP util -ping. We'll tack that up with a Y, and away we go. It's very, very quick. And just incidentally, that we are updating already proves that we have connectivity at least out to the internet, but we don't know yet what our IP address is. Let's go ahead and if config, and here we have it. As we configured it, 10.30.0.123, and that is, we'll exit, IPA grep. Heck with it, why don't we just go if config, and we'll grep that down just so that it's a little bit easier to handle. And you can see that is different from this. So away we go. Mac VLAN allows you to have a container deployed that is in a completely, it has a different IP address to your Docker host. So hope that is helpful. Try to master those 4 network types. There are others, but those should get I think the best mileage for you. And I guess if you have any questions, toss them in the comments below, and I'll do my best to answer them.